Okay, this is the paper of November 96, alternative A, question number 1, 2, and 3 that you attempted. Some important features, please. Just make sure that these are known to all of you. When you fill a table of mass, make sure that you have the same number of decimal places everywhere, and that it is a minimum of 2 decimal places. In some schools, you would have balances that can measure up to 3 decimal places, so don't forget to write them properly. Put zeros at the end to make sure that we have the same number of decimal places. In some papers, I found that the number of decimal places were not correctly written. Secondly, we come to now the temperature. So remember that all temperature should be written to the nearest 0.5 degrees Celsius, and that you need to write 0.0 everywhere, or it is 0.5. Now, Cambridge will come to know easily that the values are not written properly, or you have wrongly take the value if you don't place the 0.0 or the 0.5, and you will lose mark for the whole paper. When we come to this part now, the part A, I think this is part A. If 4.3, whenever you read this sentence, if 4.3 raised the temperature of 1 centimeter cube by 1 degree, this means that you have to use that formula. And remember, it is this only formula that you can use. Delta H equals to minus MC delta T, where M stands for the volume of the solution and never the mass. So never mass of the solution. And here it has correctly been done, which is 50 times 4.3 times 3.0. You see, again, the nearest 0.5 degrees Celsius. The answer is always in joule. How many moles of HCl were used? That was easy. Number of mole equals to concentration times volume over 1,000, and that amounts to 0.05. This is part C. So how many moles of sodium hydrogen carbonate were used in the plastic cup? That is the mass over the MR, which is 0.042 moles, again, correctly done. Coming with now calculating delta H for the reaction. This part was wrongly performed by many of you, so make sure you understand what I'm saying. This reaction is not a neutralization, so not a neutralization. Why it is not neutralization? For many reasons, like we have the formation of carbon dioxide, and sodium hydrogen carbonate is not a base, and for a neutralization reaction we need an acid plus a base. That is why this reaction is not referred as neutralization. So if it is not referred as neutralization, you should not calculate for 1 mole of water. This calculation for 1 mole of water is when it is only for neutralization. This is not a neutralization. So what do we do in that case? We calculate for 1 mole of limiting reagent. Right? Calculate every time for 1 mole of limiting reagent. So 1 mole of water should not be the case because it is not a neutralization. Many of you, you calculated for 1 mole of water at the end. So look at this one, 0.042 moles of water. So why water? We don't need water. There's no need to calculate for 1 mole of water, but we need to calculate for 1 mole of limiting reagent. In that case, the limiting reagent happens to be sodium hydrogen carbonate. So this is limiting reagent, and fortunately 1 mole of the limiting reagent equals to 1 mole of water. So the final answer is accepted. It is still a correct answer, right? But the procedure, the method is not correct. It should not be. It should be 1 mole of 0.042 moles of the limiting reagent is giving you so much of heat, and 1 mole of the limiting reagent is giving you this answer. Same for experiment 2. The tables now should be correct to the same number of significant figures or decimal places. As you can see, 3 decimal place here, and in the previous table it was 2 decimal place. Obviously they are not the same candidate, so that's why we have 2 different values, but still we have consistency between the values. 3 dp every time. This is important. For the temperature, this time the candidate plug it property nearest 0.5 degrees, so 36.5, 28.5, 8.0, so everything is properly done there. 4.3, remember, when you read this, we have to use the term delta H equals to minus MC delta T. Now, this candidate did not use that equation, but calculated it differently. So we have to plug it in the expression and see to it if it is correct or not. I won't ask you to calculate in this way. I'll ask you to use the equation. It's better. Delta H equals to minus MC delta T. Next part of the question, how many moles of HCl were used? That was properly calculated, nothing difficult. How many moles of sodium carbonate properly calculated again? Nothing difficult about it. The MR being 106, the mass being 4.6. Now, coming to this equation, many of you did it again wrong by looking for the limiting reagent. As I have written here, the limiting reagent is supposed to be HCl and it is not supposed to be sodium carbonate. So you need to check back from your answer. Quickly, what I can tell you, based on the number of moles that we have, so 0.04 moles of sodium carbonate, 0.04, and the other one is 0.05. So quickly, 0.04 is going to look for 0.08, but we have only 0.05. That's why this is limiting reagent. Alternatively, 0.05 of HCl is going to look for 0.05 times 1 divided by 2. It's going to look for 0.025, but we have 0.04. We have more than 0.025, so this is the excess reagent. Right, so this is a part where most of you wrongly calculated it. You wrongly figure out which one of the two is the limiting reagent, and it is supposed to be sodium carbonate. Oh, sorry, it is supposed to be HCl. Once we know HCl is the limiting reagent, now what do we do? Remember, it is not a neutralization because of carbon dioxide, so we don't have to calculate for 1 mole of water. Some of you calculated for 1 mole of water. No, we need to calculate for 1 mole of the limiting reagent. So what do we say in that case? 0.05 is giving so much of heat, 1720, yeah? This is the amount of heat, minus 1720. 1 mole of the limiting reagent, you get the answer. Right? I hope that this is okay now. The next part now is about this equation. I told you that you can do it by using the Hess diagram, or you can do it by using the algebraic method to look for this. Right? So this is something that I have explained. You can see that this candidate did it in a certain way, which is quite correct, but you can also try. This one, you have to try it by yourself. And you should add actually the two equations that allows you to get the third equation. And when you manipulate the two equations, you have to manipulate their delta H similarly. Right, so this is part of an answer that I have written in most of your papers. If you have difficulty, you need to consult and you need to talk about it. Yes, question number 2. There were no big issue about question number 2, apart from most of you are still not writing. Most of you are still not writing 2 decimal places for the burette. So please, burette should be 2 decimal place and should be nearest 0.05. It has to be so. Otherwise, you will lose mark. Like this one also was not 2 decimal place. Another mistake here for this candidate is that the values are not accurate. 26.5, 26.3. Accuracy should be when we have 0.10 centimeter cube difference. So the values were not accurate. And the tables, you did not complete it to 2 decimal places. So make sure that this is done properly next time. Everywhere, 2 decimal place. Right? The calculations, they were not so complicated. So look at the value here, 2 decimal place again, don't forget. And this is properly written as 25.0. There are candidates that wrote 25, which is not properly written. It has to be 25.0. Calculate the number of moles of sodium hydroxide. That is okay. There's no difficulty there. How many moles of HCl were used in this titration? Now, from the equation, 1 mole of HCl is reacting with 1 mole of sodium hydroxide. So the number of moles of HCl is still the same. Calculate the number of moles of HCl. Now, in this question, HCl was found in the burette. So here we have HCl, and here we have our sodium hydroxide, NaOH. We calculated the number of moles of NaOH below. Then we calculated the number of moles of HCl to be the same, right? If this is X, this is X. Now, how much of HCl was there in 250? So this HCl now, which is in the burette, it came from the volumetric flask. So that came from the volumetric flask. Now, this is probably a volumetric flask. Make as if it is a volumetric flask. Voila. It came from the volumetric flask. Of course, this is going to have 250. So most of you took the value here, and you took this value, and you multiplied by 10. Why? Because you know that the issue between a volumetric and between a pipette is 25 and 250. So there is a factor of 10. In this one, there's not a factor of 10. There's a factor of titer value. So most of you were mistaken, like in this one. You said in 25, there are so much. In 250, there will be so much. It's a mistake. It should not be. It should be in 28. That is your titer value. Like this here, you have so much of moles. Then in 250, it is 250 over 28, over your titer value. So that is a mistake that you should be careful about. Once you have obtained the number of moles in 250, now this was diluted to obtain the 250, and you took 22, 22.5, 22, 23, you took so much, 22.5 in that case. So this number of mole here, Y, is the same as number of mole here. Now that you have number of moles and you have volume, you can calculate the concentration like I calculated it. Right? So make sure that you have understood properly how the calculations are done. With this small scheme, with this small diagram, it makes the whole thing easier to understand. Coming with question number 3 now. This is your salt analysis. Catastrophic for most of you. Catastrophic. You still, you need to remember all the notes that I have given, and I also ask you to use your paper, to use your copybook. So you should have obtained proper answers. Like at dilute ammonia. Ammonia is testing what? Ammonia is testing cations. And you need to copy the answer from the qualitative paper. So qualitative paper. You need to copy that answer there. It should be the same. From the qualitative paper, you look for ammonia, and you look for the closest answer that you have obtained. In that case, you obtain a dark blue. So I would say a pale blue precipitate, not a dark blue. It is never dark blue in that qualitative paper. Go and look for it. It is a dark blue. It is a pale blue precipitate, which is soluble to give a dark blue solution. You only have to copy and paste what is there in the qualitative paper. And this is something that you never did. So that was one of your mistake. Yes, possible presence of Cu2 plus, that is fair enough. Now you add sodium hydroxide. This is also testing cation. Now when you heat with sodium hydroxide, now this part here, you are testing ammonium. So you need to look for the notes. A pale blue precipitate is formed which is insoluble in excess. You see that is properly written. When you warm, you are testing for ammonium. So you're looking for a pungent gas. There was nothing written here, so you did not attempt this part of the question. That's why it is a mistake. So it should be a pungent smelling gas, turning damp red, it must be blue, and that the gas is ammonia, and that it contains ammonium ion. The presence of Cu2 plus is therefore confirmed again, and the presence of ammonium ion is also confirmed. So you should know that sodium hydroxide followed by warming is testing for ammonium. And this part B was more about testing for ammonium, like testing for Cu2 plus. Because Cu2 plus is very easy to test with ammonia. That one was fair enough. But the Cu2 plus, but the ammonium ion was mostly tested in part B. Right? So remember, all your answers should tally with the qualitative paper which is provided. And gros papier na la bala, kod la fenêtre la bala. So go and see the answers there and don't give other answers apart from what is there on that paper. Add dilute nitric acid. Catastrophic encore. No visible change. Fair enough. That is good. This part is good. No visible change. So good. No visible change. Then what? When it is no visible change. So when we add an acid, we don't have any visible change. It is absence of sulfite, absence of carbonate, CO3, and absence of nitrite, NO2 minus. You see? So this is not written there. It's a mistake. Followed by silver nitrate. Now, silver nitrate is testing for halides. So that was fair enough. A colorless solution, absence of halide, you have not written. Right? So this is important. Otherwise, your salt analysis is not so good. Next one, add HCl. No visible change. Oh, sorry. Yes, no visible change. Then this is again absence of. Now, either you wrote it before or you write it here. Or you wrote it before and you don't write it here. Because that is the same test. Addition of an acid, absence of them, as you can see, right? And followed by barium chloride, that is testing for sulfate or sulfite. But we know that sulfite is not there. So now we can confirm, because we got a white precipitate, that sulfate is present and not sulfite. So possible presence of sulfate. White is not sulfite because we have already said before by the addition of the acid that there's nothing happening, so absence of sulfite. So the cations avec un gros S, some of you wrote only one. So the cations were copper ions and ammonium ion, and the anion was sulfate. Right? Now, this part was easy. How can you detect carbonate in a mixture of copper carbonate and magnesium carbonate? So that was supposed to be very easy. You add any acid and you expect to have brisk effervescence, but you should write the test. Some of you wrote here carbon dioxide formed. Maman. Moi, il est trop sali. Il écrit quand gaz a sorti, il écrit carbon dioxide sur la tête. So you should write the test. Gas evolved that turns lime water milky, then the gas is carbon dioxide, and that the analyte contains carbonates. Of course, there was no need to do the practical because you know how to test it. Right? So I hope that this makes the paper easier, and keep the video and you can use it every time and you can use it. Now, these are some common mistakes that I found when I was correcting them. Not all mistakes are on the same paper, and I have not taken pictures of the names of the candidates there. So there are some mistakes taken bits and pieces from papers to papers, and the most common ones. So now you know you can learn from your friend's mistake. Voila.